The night sky was like a dark tapestry with stars like gems woven into it. The Carina, Sagittarius arm extended as a giant depiction of existence itself. Nellie watched the view with wonder and contemplation. "Papa, those stars look very near, as if we can touch them if we fly in the sky." Actually, you can't. The nearest star is almost 4.24 light years away. Its name is Proxima Centauri. How far is that in kilometers? Quite a long way, almost 40 trillion kilometers. Distances in space are so vast that we don't use kilometers to talk about them. We use light years. What is a year? From our point of view here on Earth, a year is the time it takes Earth to orbit the Sun, our star, one time. It is approximately 365.25 days. A day is the time it takes our planet Earth to rotate one time around its tilted axis. So, as you are 13 years old, the Earth has orbited the Sun 13 times since you were born. That's fascinating. Is the light year the same? Not exactly. Light is the fastest object in the known universe. It travels at a speed of almost 300,000 kilometers a second. To put this in perspective, light can circumvent Earth 7 times a second at the equator. It takes light less than a second and a half to reach the moon. Wow, that's really fast. Yes. However, even for the mighty light, it takes a considerable amount of time to reach other celestial bodies. For example, it takes light about 8 minutes to reach us from the Sun, a little less than 13 minutes to travel from the Sun to Mars, and almost 43 minutes to reach Jupiter. That's amazing. What about the other gas giants? Saturn, about 1 hour 20 minutes. Uranus, about 2 hours 38 minutes. And Neptune, about 4 hours 10 minutes. So, if the closest star to us is more than 4 light years away, that makes it really far. If we were to embark on a space voyage using our current rocket technology, it would take us hundreds of thousands of years to reach that star. So, how far is the Carina, Sagittarius arm that we are looking at now? Somewhere between 25 and 30,000 light years. Oh my goodness. And I thought we could touch it. What's more, the Milky Way galaxy is a staggering 100,000 light years across. We live in a gigantic neighborhood. What is the Milky Way? It's what we call our galaxy. It is a collection of more than 400 billion stars orbiting an enormous black hole called Sagittarius A. What is it doing there? It's holding the stars of the galaxy together. Is it big? Sure. To put it in perspective, do you know how big the Sun is compared to Earth? Maybe 100 times bigger? Nope, almost 1 million times bigger. What? Do we live on such a tiny planet? Yeah, Earth is quite a small planet. Now think about Sagittarius A. Its mass is 4 million times bigger than the mass of the Sun. Oh my goodness, that's really massive. Yeah, you're absolutely right. Are we lonely? I mean, if all stars are so far away, it means we are lonely with the Sun and the other planets. We will never reach the nearest star. Not exactly, not in a spaceship, but in another way, we are already deeply connected to those stars. You are looking now at our primordial home. What do you mean? How can we call such distant places home? Let's break it down. You've studied in your biology lessons at school that our blood has hemoglobin in it, and that hemoglobin has iron, hence the red color, right? That's true. What is iron? Iron is an element. An element is defined by the number of electrons orbiting its nucleus forming the atom. There are 26 electrons in each iron atom. Yeah, we've studied this in chemistry. Our sun works using nuclear fusion. It means that it fuses every 2 atoms of hydrogen to form 1 atom of helium. This fusion releases immense energy, which keeps the sun emitting its light and heat. That's fascinating. So, did the sun make us? No, my dear daughter. The very iron in your blood didn't come from the sun. Where did it come from then? To answer this question, we have to know that there are 3 types of stars. Medium-sized stars, like the sun, massive stars, more than 8 solar masses, and very massive stars, greater than 20 solar masses. All those stars rely on nuclear fusion to sustain the balance between their tendency to collapse on their core due to their gravitational pull and the likelihood to explode due to their nuclear emitted energy. What happens to those stars when they finish their gas? You mean when they exhaust their fuel? We need to categorize them into 3 categories. Medium-sized stars. These stars exhaust their hydrogen fuel and expand into red giants, then shed their outer layers, leaving behind a hot core. This core becomes a white dwarf, which gradually cools over time. Massive stars. usually more than 8 solar masses. These stars undergo fusion of heavier elements in their cores until iron is formed. When fusion can no longer produce energy, the core collapses, resulting in a supernova explosion. The core remnant can become a neutron star. Very massive stars. These stars also undergo fusion until they create an iron core. Upon core collapse, they can produce a supernova. And if the core remnant is massive enough, it collapses into a black hole. I don't understand anything. What is the relation between star explosions and us? When a star collapses on its core, the immense energy and gravity fuses elements and generates heavier ones. So, the iron in your blood was actually created in that supernova explosion. We are the children of the stars. And how did that iron and other heavier elements reach us? After the supernova explosion, the star remnants drift in the cosmic void as a nebula. Our entire solar system, including the sun and the material that became Earth, formed from a cloud of gas and dust that was seeded with these heavy elements from long-dead stars. When the Earth cooled down, those heavy elements became solid enough and mixed with the soil to be later used as raw material by DNA to weave the tapestry of life. I have never thought of that. I'm a child of a star. I've always thought I was a regular girl. We are all children of stars, as Carl Sagan taught us. We are the magnificent grandchildren of stardust.